Mnemic is a backend of a tracing application that we can use in asynchronous Python applications to monitor performance, including memory allocation, active tasks, and many more. It can be found in GitHub under GitHub Coding is my craft Mnemic, as you can see in the screen. And in the README file, you can see a high-level view of how this works, meaning the Mnemic server that we see in the middle of the screen is a service that can be installed in any machine. For the purpose of this example, we're going to install it in localhost. Mnemic exposes a front-end API that can be accessed by a browser and show the statistics, and also it can interface with any Python application to receive tracing messages in a periodic fashion. The data is stored in the database. Let's go and create a Hello application and see how it can be installed and used. The first thing is to install the backend, which can be installed from Docker. As we can see in this screen, if we execute these commands here, now the backend, including the database, the front end, and the backend services, is being installed. Once this is going to be installed, we're going to be ready to interface with it. I'm going to pause it for a few seconds until it finishes. Mnemic is now installed in our local host. If I do a docker image ls, I can see the three images that were downloaded: the backend, the front end, and the Mnemic DB. While if I see the containers, I can see that I have 3 containers up and running, each for each image. At this point, I can point my browser to the address 12.11.11.1, and I can see that I have an empty screen that because I don't have any data yet there. So now let's create a toy application to update the backend. For this, I need to install the library called Dolon, which is installable directly from PyPy. It was already installed, so nothing happened, but now we are ready to write the Hello application. So let me create a directory, call it Mnemic Hello. I'm gonna start VI. And I'm gonna copy the Hello program from the README page. What is happening here is that we have an application, just called main, which runs into an infinite loop and calls a function called time and memory consuming function periodically. And this is a dummy function that is creating an array of 10,000 integers, and then it slips, and then it goes out of scope. If I want to monitor the performance of this application, I have to include the dolon.trace client, as you can see here. And before this, I usually start the trace malloc as early as possible, which this is going to allow us to have valid memory snapshots usage. Once I write this tracer function here, where I specify the name of the tracer, the host, which in this case is localhost, the port where this is listening, which in this case is 12013. This was assigned in the Docker assignment, and the frequency, meaning how often is going to collect data. I can start tracer using the start tracer function of Dolon that is implemented in Dolon. And as you see, I'm passing tracer name, frequency, host, and port, and after this I am passing some functions. These functions, mem allocation, active tasks, and CPU percent, are built in the trace client. And what they do is obvious, meaning they collect the memory allocation, the active tasks, the active asynchronous tasks, and the CPU percent usage for the time this function is going to be called. We can add any other asynchronous function to gather custom statistics. It doesn't have to be one function that is implemented in trace client. The only requirement is to be an asynchronous function and to take no arguments and to return a real number. So once I write this tracer function, the next step is, before I start the main entry point for my program, to be sure that this is scheduled as a future. And this automatically is going to start the tracer, which is going to gather the statistics and is going to inform the backend. So now that we have this ready, we can start it from the command line. And now you see that it's tracing some messages here. Now if I go to refresh the page, you see that hello world, which is the name that we named our run, appears in Mnemic, and here we see the time we started this trace. If I click here, I immediately see in the right side the statistics that I requested: memory allocation, active tasks, and CPU percentage. If I stop the application and restarted it again, and I refresh the page, we're going to see that a new run is being added. So we can have as many runs we need for under the same name. Now, if I want to add or remove some statistics from my tracer, I can easily do this. For example, let's pretend that I need a custom function, which I call it gather junk, which is gonna gather some statistics. And let's say that this is gonna be a random number for now. And let's say it's gonna be anywhere from this array here. This can be anything, meaning it can be the size of a file, it can be the number of database connections, or whatever else. The important thing is that this is an asynchronous function, it takes no arguments, and it returns a numeric value. So in this case, if I take this function here, I can add it here, and then if I restart my application, now I'm gonna see yet another run, which is gonna have the gather junk run. This is a correlation between all the statistics that we're gathering here, meaning we can see how correlated these curves are to each other, and this has been used for more advanced monitoring, and I will not get in deeply into this for the moment. So this wraps up pretty much the hello world explanation of it. To see a detailed documentation, you can go to the read the docs page of the project, where the full API is documented in detail. Thank you so much for watching, and I hope you find this a little bit useful. Thank you.